Hello everyone. We have a question. It says that by using a suitable substitution, solve the equation. And the equation is 2x minus 3 with a square minus 4 upon 2x minus 3 with a square minus 3 equal to 0. If we observe the given equation, we can see that we have 2x minus 3 with the square over here as well as 2x minus 3 with the square over here. They both are same, so we can use any variable other than x and substitute these two. So we just took y as a substituted variable for 2x minus 3 with a square. So instead of this we have written y, and instead of this one minus 4 upon y minus 3 equals 0, we have done the same. Now simply rearrange it so that it could be converted into a proper quadratic form. So the denominator over here is y, the denominator over here is 1, the denominator below 3 is also 1. So multiply this by y in the numerator as well as the denominator like we have done over here, and similarly multiply this 3 by y and divide by y as well, so that all the denominators would become y, so that we could write the complete into a single fraction. So this y times y becomes y square minus 4 and minus 3y divided by y equal to 0. And when we go for cross multiplication, this y when multiplied by 0 would become simply 0, and after rearranging it, it would become y square minus 3y minus 4 as we have done. So finally we have a proper standard form of quadratic equation. We can use a quadratic formula, and after using the quadratic formula, just place the values of a as 1, b as negative 3, c as negative 4 in the quadratic equation, simplify it and get the two values of y, which are 4 and negative 1. These are not the final answer. These are basically the two values of the substituted variable, which was y. But y is equal to 2x minus 3 with a square. So instead of this y, we can write 2x minus 3 with a square equal to 4 and equal to negative 1, like we have written over here, that 2x minus 3 with a square equal to negative 1 and 4. Now because we need the answer for x as it was written over there, solve the equation, so definitely we need the value of x. So taking square root on both sides so that we could remove this square, and after taking a square root on this and square root on that, if we just take the square root of this one, we can see we had a square root on the negative 1, and definitely we don't have an answer for negative. No real solution would become, therefore definitely there is no solution for such kind of condition. But if we take the square root on this side, definitely it would result in a positive and a negative value for the square root of 4, which is 2. Now we can have two answers if we use positive 2 and negative 2 and just rearrange it. Just move this negative 3 on the other side to make it positive 3, and after that finally dividing by 2 and getting the two answers, which are 5 upon 2 and 1 upon 2. So these are basically the two values of x, which are basically the solutions to the given equation.